going through 50 challenging problems of probability, and question number 6 is called Chuck-a-Luck. Essentially, Chuck-a-Luck is a gambling game often played at carnivals and gambling houses. A player may bet on any one of the numbers 1 through 6. 3 dice are rolled. If the player's number appears on 1, 2, or 3 of the dice, he receives respectively 1, 2, or 3 times his original stake plus his own money back. Otherwise, he loses his stake. What is the player's expected loss per unit stake? So before we begin, I want to define 2 variables. T would represent essentially the unit stake. We'll have G represent the player's guess. When we play this game, there are essentially 4 events or cases. There's a case that none of the die represent the number we guessed. There's a case that 1 die represents the number we guessed and the other 2 don't. There's a case that 2 dice represent the number we guessed. And then there's the case that all 3 dice represent the number we guessed. I'm just gonna write that down here. Okay, so for each of these cases, let's calculate how much of our stake we get back. So in case 1, where all 3 of the dice land on our guess, we get 3t plus our original t, which equals 4t. And for case 2, if only 2 of them land on our guess, we get 2t plus our original stake, so we get 3t. For case 3, where only 1 of the dice lands on our guess, we get 2t. And for case 4, we get nothing. So to calculate these probabilities of each case happening, we can represent the successes as binomial random variables. Okay, now that we have the probability of each case, we can find our expected return per unit stake. So this means that each time we play the game, we're expected to make this much. Because we're asked to find our expected loss, we just subtract this from a full stake. This portion of our stake is our expected loss per unit stake. Thank you.